Thank you for viewing my talk about the Luminescence Imager for Exploration, or LIFE, an autonomous microscope. This talk is to recap the work I did this summer. I have the privilege of working on this project, however, for the next year and expect that my reporting will only become more exciting as time goes on. I'm an undergraduate student at Skyline College in San Bruno, California, and I'm certified in advanced light and fluorescent microscopy techniques from the Merritt College in Oakland, California. As the McKinsey et al. Paper explains, since the Viking mission of the 1970s, no flown NASA missions have been specifically designed with the primary goal of searching for evidence of life, past or present. Instead, subsequent planetary missions have focused on searching for and characterizing environments that could support life as a prerequisite to searching for evidence of life there. The Decadal Survey, released in April of 2022, gave NASA the recommendation to search for life in watery worlds, and this is translated into institutional goals and objectives at NASA. The Luminescence Imager for Exploration, or LIFE's science goals and objectives, simply put, are to search for life on a microscopic level in watery worlds like the moons of Saturn or Jupiter. The device will identify and characterize morphological and textural indicators of life for both inorganic and organic factors, while also assessing habitability. So how do we detect life with a microscope, you might be asking? What features will we use? Well, we have bright field, UV, and deep UV capabilities and LEDs that will excite the autofluorescence in the samples. We will be using a specialized freeze-dried process to fluorescently stain key biomarkers that indicate life, like proteins or lipids. And there are embedded environmental sensors to help regulate the device and the environment. This is a fully autonomous image capturing and processing tool that is designed for exploration of life in watery worlds. Here you see a schematic of the scope itself, and the most amazing thing about this scope is the small microfluidic scale that is the design itself. On the right here, you see the process that the sample will take through the staining microfluidic process into a rotating disc that will filter the particles and be imaged by the microscope. On this slide, you see an example of how the scope will take an autonomous image. The LIFE device incorporates 50 images collected along the z-axis and then divides them into tiles, with one tile from each stack that is in focus being selected and stitched together to form a single in-focus image at the end that is sent back to Earth. Isn't that amazing? Here we have an example of an image that was made from a z-stack of a flywing, which we know has a lot of morphological changes along the z-axis. The detail of the image is greatly increased by this imaging process program. Some of the highlights briefly of my summer work has been really to dig into the back end of this microscope and to characterize the camera and functionality of the scope by collecting data and analyzing it with the team. For example, we determine what the noise floor is and how to control it, as well as validating all of the scope's presets. I've also been able to mock up the microfluidic staining process, as you see here in this image on the right, and we'll be automating the functionality of this process as I proceed to take images using ice and other biological samples from Antarctica. Finally, I am proud that I was able to work collaboratively with a cross-functional team of electrical and software engineers this summer. I gained their trust and even was able to brainstorm and offer solutions for issues we were facing. One of my suggestions was recently implemented by the team and reduced the latency of our live viewer functionality by 2/3. I learned to not be afraid to speak up and dive into the team. This is a core value of mine, wholehearted participation, and I'm so glad I got to practice it this summer. I look forward to the year ahead and working on the next phase of this project with my mentor, Richard Quinn. A big thank you to the entire team that has participated in making life happen, but especially my mentor, Richard Quinn, and Blue Barnwell Space Institute that has recruited me into a world that I would have never imagined was open to me here at NASA. And also a big thank you to our funders, the Maturation of Instruments for Solar System Exploration, the MATIS program.